It's a pleasure to be here today, back in London. It's been a while since I've been into the city. I was just saying how much Broadgate Circle has changed, and it's amazing. My name's Alex. I'm an engineering director at Canonical. I run the Kubernetes teams there, so micro-K8s, Charmed Kubernetes are the things that we build. And outside of work, I do some other stuff for the CNCF, as well as contributing to Open Feature, which is what I'm here to talk to you about today. Aside from that, I also wanted to mention I do run a channel for folks who are senior engineers that perhaps have run out of content. So check it out if you're interested in that as well. It's all around the cloud native ecosystem. So I want to start off with a quick poll. You can just hold your phone up, click the QR, and it takes you to the right website. This is the only audience participation, I promise. And figure out, what's the kind of consensus on feature flags in this room? Like, yeah, I thought maybe that would be the first up. Do you use feature flags? Not really. Yeah. Sometimes? Okay. We're going to see a normalized distribution, it looks like, in a minute. Okay. Interesting, right? Feature flags are something that I think we probably rarely use, but probably a lot of us know what they are, right? It's a simple concept. Cool. Let's try one more. You can just hold your browser open and it will change your page for you. What comes to mind when you think of feature flagging? And again, if you've just joined us, click on the QR code and you can put in some words. What do you think of when you think of feature flagging? Before I started participating in the project, there were certainly things that I thought about feature flagging. Yeah, A/B testing, feature testing, looking at geofencing, that kind of stuff. Turn it off and on again. That's a great one, yeah, exactly. Tenant-specific settings, I like that. And releasing safely. And being able to release new features safely in a way where we can actually have some data rather than just throwing something out there and seeing what happens. Awesome. Well, thank you. And you can keep writing if you want to, and I'll look at these later. So thank you for participating. What is feature flagging? A colleague of mine on the Open Feature project, Pete Hodgson, wrote a great piece on the Martin Fowler website around feature flagging. It's really extensive. And it describes effectively what is it in a nutshell. And I could talk a lot about it, but I think that this is quite a succinct way of describing it. It's a set of patterns that helps the team to deliver new functionality safely. If you're reductive about it, yes, it's just a set of patterns. It is a technology, it is a wrapper, it's an SDK, etc. But fundamentally, it's how do we deliver something safely. Oops, I'll pop that down. Now, what's interesting about that is probably you, a little bit like me, think that feature flagging really just occurs in the browser, or like the browser talking to the backend server. Let's say you have a React application that is talking to a Flask app running somewhere, and maybe a feature flag might be based on something. What is that something? Why would you use a feature flag, and how would it work? Well, the simple one I mentioned a moment ago is geofencing, right? That idea that if my IP address comes from a certain block, then I get certain content displayed. And then there's also the server side. As I said, that could be that if I am doing server-side rendering, then it returns a certain type of page. So that's a traditional look of feature flagging. But today what I want to describe to you is going beyond that conception of feature flagging and look how does it fit into the cloud-native world and how does it fit into Kubernetes. So before we get there, we need to sort of take a step back and think about how does feature flagging actually work? Well, in principle, it's quite simple, but there are a lot of bells and whistles you probably don't think about when you are actually writing one. You have what's called an evaluation context. So I described having metadata. That could be your geofencing data from your user agent. It could be something in the API call. It could be effectively something you decapsulate off the TCP packet. That needs to be evaluated, right? It could be a regex. You could be checking for certain values. You might cache the response, right? And then there's a synchronization between the provider. We've all heard of providers such as LaunchDarkly, Flagsmith, etc. You need to be able to synchronize that data. Probably not in real time because it's not effective if you're running this over 1,000 applications. So there's a lot of bits that make up feature flagging that are unique to the provider. And that's kind of the problem. These are three different providers, right? I've got Flagsmith, you can see in the middle there. I think LaunchDarkly is at the top, or maybe the bottom. And they all have their own SDKs. The SDKs all work in a unique way. And again, they're all really heavily biased towards client-side feature flagging, either on mobile or desktop web browsers. Even further, the problem is that they all have their own set of primitives and evaluation methods, meaning that they all decide whether a feature flag should be shown or hidden based on a different kind of context and a different kind of set of requirements. And so there's a perfect opportunity here because not only are feature flags really only for desktop and for mobile and for backend servers. But there's a whole bunch of stuff that we could do thinking about other projects that have been successful in the cloud-native ecosystem. So what do I mean by that? Some of you might be familiar with OTel, so Open Telemetry. Basically, a consortium of vendors got together and said, well, they said telemetry is great, but we've got open census, we've got effectively open tracing. We need to kind of put these together and bring these to not just Kubernetes or not just the browser, but also what about machine level? What about all these different layers of the infrastructure that we're not really able to achieve because we don't have effectively a homogeneous API across all these layers? So the needs were apparent that we need something vendor agnostic for feature flagging that gives you interoperable components. That might be a JavaScript SDK, it might be a Go SDK, it might be an assembly SDK, it might be a COBOL SDK, but they all need to use the same kind of schema. And that, again, harks back to OpenTelemetry. It uses a schema so that the vendors build around that schema. And we also want to do complex evaluations, right? Not just, where's my geofence, but does my email address end with this, and is it before the 31st of October? If so, then this feature flag is a true. Or it might even be an object that it returns. And the last thing is that it needs to be cloud native in its design. So in principle, it needs to be fairly discrete, something that can be uplifted and moved between different types of project and interoperable between those projects. So that's where Open Feature comes in. Open Feature is a new CNCF project that is currently in sandbox, and it is a standard for feature flag management. It's a unified API, and it's developer first. And why this is really exciting is because when you start unifying a feature flag API, you can take it anywhere. It offers a simple API. You'll see in the slightly blurry text here that get client returns you a client, get a Boolean value, get a string value, etc., etc. It's flexible in that you can extend it. So for example, you can create a TypeScript or a Java SDK, and you can extend the functionality so that for your particular company, if you want to resolve a feature flag to do something in particular, you can extend the SDK very, very easily. And equally, it supports powerful extensions such as before and after hooks on the feature flag. So it started this year in 2022, 20 founding companies. I was one of the founding members, along with several folks from Dynatrace. Again, as I mentioned, we have contributors from eBay, from LaunchDarkly, from Flagsmith, and from many more esteemed companies. And the idea is that all of these folks want to get together and build something that can be used ubiquitously throughout the stack, but also it decouples users from being tightly coupled into those feature flag providers. Now, this is really strange because I'm not a feature flagging person. I'm not even an OpenTelemetry person anymore. I work in Kubernetes. So how did I get involved in this project, and why am I talking to you about it today at Kubernetes Community Days? If you think back to Valencia, for those of us who were lucky enough to go to KubeCon this year and have a lot of fun there, I happened to meet some of the open feature folks there, and I got chatting to them. I knew them through my affiliations with OpenTelemetry, because Dynatrace is a contributor to OpenTelemetry. I have friends from the CNCF tag app delivery, and we were chatting. We thought, hey, well, this is really interesting for bringing web and client-side feature flagging into a really vendor-free area. But what about, server-side? What about going into SDKs? What about pods? Can't I have a feature flag in a pod? Can't I do this on my Linux machine? And so I couldn't sort of sleep without thinking about this question of, well, what if we go beyond the browser, right? What if we could do feature flagging in Ubuntu? What if we could do feature flagging on an embedded device, so that if I took the device out of the factory, the API call return would differ based on if it was inside, based on a feature gate and a decision that was made? What if we could do feature flagging for shell, for system apps? What if we could put feature flagging in the kernel, so that depending on system configuration, we could return feature flags back based on the input? And so it became a very interesting thought experiment to see where we could take it. And so that's where I sat down one day and thought, let's think about how this would actually look if we were to take a Unix view of this. So I wrote something called FlagD, which is a system daemon for any Linux distribution. It runs on 9 different architectures. And the idea is that it is a very lightweight, very modular way of evaluating feature flags. But what does that actually mean? It means you give it a file, you give it a remote endpoint, or you give it a bucket, any type of source, and then you give it the ability to serve these. It can be a gRPC server. It uses the gRPC Connect library in Go. If anyone's used that, that's a multiplexing library that lets you multiplex protocols off the same socket, which is a very big mouthful to say. But effectively, it means we're trying to do a lot with very little. So this little binary that runs as a systemctl service, a systemd service, can effectively take feature flags, and you can talk to it. So one kernel module can talk to this, or you could use a user space application or a shell script. One of the first things I did to see how this worked was I just ran this locally, and I wrote a bash script that effectively it queried it and said, is this kernel module turned on and off? If it is, return the right feature flag. So in principle, FlagD was this experiment of how do you get something simple. I think this is supposed to be a GIF, but it doesn't quite render in this. But it's supposed to be how do you get something simple and how do you display it? Now, what I would be showing you here, and I apologize for my slides, is that on the left and the right, you get a client and a server, effectively, right? One is running FlagD, the other is doing a curl, or the other is using gRPC and saying, is the bool red? Yes, is it red? Yes or no? Or what is the default color on this background? It returns a color, as I described earlier on. So FlagD was a really big success in that initial exercise to think about how do we take feature flags out of the browser? Already, having something that I can just go FlagD run, oh, by the way, this is a snap as well on Ubuntu. So if you just go snap install FlagD, you've got it, boom. You now open up a lot of doors, because if I'm a programmer who does Rust, or if I do, as I said, COBOL, C++, any of these languages, I'm not in the web browser unless I'm using some weird arcane framework. I'm running on the command line, or I'm running as a service. Suddenly using FlagD, I could talk to FlagD, and FlagD could talk to Launch Darkly. So therefore, from the web, somebody can turn something on and off that does something inside of my application. And that's really powerful. And fundamentally, I think it's changing the landscape. So how does FlagD actually work? I mentioned a little bit about this idea of sinks and services. I've drawn a little diagram here with Excalidraw. And what you can effectively see is it's got a bunch of components, an evaluation engine, an update system, a pretty robust socket interface, but effectively just means that you can serve FlagD on a bunch of different ports and a bunch of different protocols. What's really interesting is that host process can effectively be anything that can talk via Unix, via AF Unix socket, which is most technologies. What I mean by that is if you can talk HTTP, you're good. If you can talk HTTP2, you're good. If you can talk even down at the socket level, it has a basic protocol, you can talk as well. So we've really tried to make it super wide so that anybody could integrate their system to FlagD. But this didn't really feel like a finished product, right? This didn't really feel like this is something you could put into the CNCF and people would be able to consume it very easily. This is more like a niche hobbyist thing for maybe someone who's writing a FAS, or someone's writing a local implementation of a program that uses gating. So I thought really hard, and by this point in time, I had some great contributors who started getting interested in trying to make FlagD cool, and they were saying, hey, well, why don't we do some stuff optimizing it? And I kept thinking, what if we can do more? What if we put this in Kubernetes? I was thinking, do we put it in the API server? Yeah, maybe, but then you can just control the API server. What if we let users who are writing those Flask apps, hosting them in pods, or Java applications in pods, or C# using like Service Stack in pods, but they could talk to FlagD and control their feature flags as CRDs. And so I scribbled this little illustration up, and it effectively described the V1 of how this would all work. And I'll talk us through it, because it's a bit of a sprawl. If you imagine you've got effectively your get fruit, right, on your local host. You're running a web application in Docker or on Kind or on micro-K8s preferably. And you're doing, hey, get fruit with curl, right? And you've port forward it, and it returns that. And that's your little Flask application. Well, with feature flagging, how do we take this a bit further? How do we start to think about using FlagD in a way that makes sense? So this is where I started talking about something called an open feature operator. I'd recently co-authored the operator white paper for the CNCF in 2020. And so it was hot on my mind, like what are operators, what is the synthesis of human behavior and all that, very, very philosophical subject. But I was thinking, really, what would this operator do? How would it make sense in this context? So I thought about it like this. If you have a container running that application, it makes sense that we inject a sidecar, and that sidecar sets up an IPC socket between your primary process and the sidecar, right? People do this all the time. There are sidecars for service mesh, there are sidecars for Jaeger, sidecars for everything. However, this is a very, very lightweight sidecar. It's running that Golang process. Oops, sorry, big reveal. That sidecar process. And what it means is you can start querying. Now, obviously I'm not going to use curl, right? I'm not going to hand crank this. I'm not going to go to the effort of starting to write my own implementation. But this was serendipitous because the SDK started coming along at the same time. Our community started growing. Suddenly we had a Golang SDK, we had a Python SDK. Now, in there, the SDK doesn't define where you're connecting to. You can put a connection string in. So what we decided to do is, hey, how about we write away the SDK automatically sensing if it's in a pod and there's a flag D pod next to it. So flag D becomes its provider. So this Python SDK here would have a bit of logic saying, by the way, I do have feature flagging enabled. Just tell me if this Boolean's available. It would go and talk to flag D, and flag D would provide the feature flag. And this is where it gets really even more interesting, because being able to interact with that, I don't always want to go to my cloud provider. Sometimes as an SRE or as a sysadmin, I might want to use a CRD. So with GitOps, I can effectively define in the CRD bananas, I could just, their weight of bananas. So when I have get fruit here, and I want to set what fruit comes back, I can set value of bananas in a CRD, which gives you the double benefit of being in GitOps and also being declarative, but also you've got that chain of auditing. I don't know if you've used a lot of feature flagging providers, possibly not, because the poll showed that, but they're usually on-off. There's not a great deal of regulatory information around who turned this on and off when, whereas if you're doing it Git-based, it's a PR, right, to turn a feature flag on and off, or if you don't want to, you can just flick it on and off in case. So this was really exciting to me because we were starting to make some inroads on effectively this new project called Open Feature Operator. Open Feature Operator, as I described, is a Kubernetes operator that injects feature flags into your existing workloads. So there's no work required. All you need to do is write your Java, write your C# application, and use the SDK. And you can use the SDK locally when you're developing in VS Code, and you can run flag_d there, or you can connect to your cloud provider. And then when you push your workload into the cluster, it automatically wires up flag_d with the Open Feature Operator and installs a CRD for you to use, and you can start modifying your feature flags. This is now a Helm release as well. You can check out the QR code. It's not an apply anymore. We moved to Helm, so you can install it easily, get rid of it if you don't like it. However, I think that if you're working in this space, you'll start to see that it's incredibly intuitive. And also, when you're working in this space, who's working in this space? Let's start thinking about what you can use feature flags for, because if you've now got feature flags at the pod level, you can start talking to your existing operators. If I have a MariaDB operator or a Postgres operator, I can inject the flag_d sidecar and start making decisions based off the feature flagging. I might disable that entire operator, and the operator checks in the first line, in the init container of that operator. I could do a curl request to the local host, flag_d, have I been disabled? Yes, exit out. So now we're bringing feature flags right down into Kubernetes, which is something absolutely unheard of. But how does this one work? Fundamentally, I showed you that kind of coffee napkin scribble a minute ago. We had to get serious with actually how would feature flags work in production at multi-thousand pod scale. The way to really do this is the following. So when your pod spec goes through the admission steps in the Kubernetes API, the first thing that happens is your pod spec will be scrutinized. It will go through the validation and it will go through the mutating admission control phase. What happens here is the Open Feature Operator says, okay, here's something coming into my remit. Does it have the right annotations? Check. Does it have a feature flag configuration annotated? Yes. If it does, then I need to do a couple of things. Does that feature flag configuration exist? If not, I can create something or I can wait based on your requirements. And I also need to look at the workload and inject the sidecar into that. It mutates the pod spec. It creates that pod. And flag_d then spins up and wires back through the API server to the original feature flag configuration. Now this is using a shared index factory informer. Again, another mouthful, we get a lot of those today. That shared index factory informer is effectively a single stream socket that persists. So for people who are thinking, oh, is it a million RESTful API calls? It's not. It's a single socket that persists over the connection. It even has a retry. It does all that jazz for you. It handles all of it. So flag_d is sorted. It talks to the API server. You can proxy it if you want. If you don't want to talk to your API server directly, you do you. You can use a Kubernetes connectivity tunnel if you want to. But what's really interesting about that is suddenly now we've got real-time updates. So when I change something in that CRD, this is lightning fast, and your workload will see that reflected. It'll be way faster than trying to do a remote RESTful API call. You think about the latency incurring and the hops, the decision making in the cloud coming back again. So where does that leave us? Well, we have now, with Open Feature Operator, Kubernetes native feature flagging. You can choose your access, you can choose your requirements, and I want to give you a quick demo of this. On the right here, and I'm conscious of time, we have effectively a program called Watchman. Watchman is an admission controller. Let's say you're working for a company, a large bank, and you've seen there's an intrusion on your cluster. You can't delete the cluster. You can't revoke all the access because you don't know who started the intrusion. But the intrusion is creating pods, and those pods are Bitcoin mining. What can you do? What Watchman does is it's an admission controller that talks to FlagD, and when it's given permission, it stamps on the validation admission controller, and it spins out access denieds. So anybody who's creating pods, they get completely squashed. So let's see how this looks, because this is driven by feature flags. It's time for a demo. And just so you know, this demo is running off this cluster, which I'm accessing over Tailscale, and that's sat in my office, so if my kids haven't knocked it over, we'll be golden. So let's have a look. So I'm going to show you that demo, and I'm hoping you can see it. So what have we got? We've got Open Feature Controller Manager and Watchman, two different pods from two different deployments. The Controller Manager sits here, it reconciles, it does its thing, and Watchman sits here, it does its thing too, it doesn't give you any logs. What I'm going to show you first, before I show the quick demo, is how the code looks. In the pod admission for Watchman, you see there's a handler. What it does is it says get FlagD value. That FlagD value comes from here. OF client, Boolean value, blocking, and then it returns that value. This is just a bit of decoration so that there's a timeout, it returns a result. But effectively it returns the value, and then it says, if the value has been set, then set the admission to denied, otherwise allow. So let's go ahead and try that. So if I just jump out, and I'm going to go into my CDK demo, it's just got a single bit of pod YAML, super simple. I copied this from somebody's blog, so I apologize. It's got a bit of extra spec. But anyway, apply, creates a pod, great. Let's delete that pod. Delete that pod. And whilst we're doing that, we should see that we might get a little bit of log saying, here's the response, we did the evaluation, and it's gone. Now this time, what I'm going to do is go into the feature flag configuration, Watchman flags. I'm going to change to turn it on. The default variant is what we call it in feature flag terminology. So that when I go back again and try and create that pod, you'll see that we have a blocked admission on that pod. And I think that's really important. I'll show you one other quick thing as well. Now this is a bit of a stretch demo. I was laughing to some folks a moment ago. But what we're going to do is I'm going to show you something called the Open Feature demo. This is a little bit more traditional for folks who perhaps do come from that web world. So we've got a Fibonacci, beautifully rendered green website here. And you know, if you're a web developer, the connection between Kubernetes and the front end can be a bit difficult to sort of think about here. So what we've got is effectively a demo running from a pod that has this client attached to it. And what I'm going to do is I'm going to use feature flags to change something. So what's going to happen here is this end-to-end demo. I'm going to change the color of the background. So you see the default variant is green. I can change that variant to red. I save that out. And what happens is this does a check on the back end. The back end then effectively updates, and then it turns to a different color. Now, of course, demo's being live. Oh, my port forwards failed me again, sorry. My demo's being live, something always has to go wrong. So it's changed to a red. So what you get is extremely fast changes to A/B testing, to chaos testing, to features in your cluster that could be a web browser. It could be a backend component such as Watchman. And I think this is an exciting future for feature flagging. So what's next? I described that we've now got this ability to feature flag inside of pods and containers. Well, the next thing we're working on is this project Artemis, which is a very strange name, which is basically to add the Kubernetes API server and Open Feature together so that you can start turning on and off feature gates inside of Kubernetes through a CRD. We're also looking at turning on and off feature gates inside of Ubuntu, being able to turn on and off kernel modules through feature flags based on conditionalities. The project has been here less than a year, and we've had incredible growth. We're looking to go towards incubation early next year. In the time that we've done 2 KubeCons, we've seen 3 production adopters of Open Feature, which is pretty unheard of. I think OpenTelemetry is one of the only other projects that had that rapid a growth. If you're interested in Open Feature, and if anything I've said today has got you a little bit thinking about, hey, I've got a home lab or I've got a thing that we're trying to do, do connect with us. We have a website and everything. You can check that out. We've got a really nice little Docusaurus site that we're trying to build tutorials around. If you're a contributor and you want to get into open source, this is a great way to do it. You might think, oh, well, JavaScript isn't super cloud native-y. That's a great thing because we've got a JavaScript SDK and we need expertise on how to do things like React components, etc. I hope you've enjoyed this. I'm not sure I've got a last slide. Let's find out. No, I don't. That's it from me, and thank you so much for listening. I appreciate it.